All right, let's do section 2.2, which is infinite limits and limits at infinity. Which tricky because they kind of sound the same. They're not exactly the same. One of them is taking the limit as x approaches infinity. The other one is when you're taking the limit and you get the answer infinity. So when we're talking about vertical asymptotes, and basically these two things are horizontal and vertical asymptotes, which you might have seen in other courses. So infinite limits, these things are giving you vertical asymptotes, and limits at infinity are going to give you horizontal asymptotes. Okay, so if I'm taking the limit, the one-sided limit, and I see that I'm approaching positive or negative infinity, then I know there's a vertical asymptote there. For instance, the graph of 1 over x is, hopefully it's a parent function you'll memorize. It looks like this. And as you can see, as x approaches 0, so that means here's 0, right? But I'm going to be on the graph close to 0. Where is my graph going? It's going up and up and up and up. So that's going to infinity. So as I'm going to 0 from the right side, I'm going to positive infinity. As I'm going to 0 from the left side, I'm going down, down, down. So I'm going to negative infinity. So we can describe what's happening from either side. Now, in order to find a vertical asymptote, what you're going to do is you're going to factor, you're going to simplify the things that may cancel out, and then whatever is remaining, you set the bottom equal to 0 and solve for x. Okay, so if I had, for instance, the function x squared minus 1, and then on bottom I had x minus 1 times x plus 3, and I said, where are the vertical asymptotes here? First, you would factor this top. When I factor the top, I see that I get x minus 1 and x plus 1 over x minus 1, x plus 3. So these simplify to be 1. But this, since I can remove it, it's not a vertical asymptote. This is actually a hole in the graph. Whichever one you simplify, that one's not the vertical asymptote. So whatever is remaining, you set this equal to 0 and solve, and that gives you the vertical asymptote. So that's if you have multiple factors setting something equal to 0. So again, that's what this is saying, that the top cannot also be 0. If the top is 0 also, then that's a hole. So it's only when you have this number over 0 where you get a vertical asymptote. So find the vertical asymptotes here. I can't factor the top, so I just want to keep 2x minus 1. The bottom factors x minus 1 times x plus 1. I can't simplify either of these out, which means they both return vertical asymptotes. So you're going to set them each equal to 0. So you're going to get x equals 1 and x equals negative 1. Those are your vertical asymptotes. This one I cannot factor out either, so I just set this bottom equal to 0, so that would be x squared equals 0 and x equals 0. Now, this is saying as I'm approaching infinity, so you're going to take the graph and you're going to look at the far right side of the graph or the far left side of the graph, and you're going to see, are you approaching are you hanging out at a value? If you're hanging out at some value, that's called a horizontal asymptote. So you can see that here at this graph, as x goes to infinity. So as x gets really, really, really large, so I'm moving this way, what is the y value approaching? The y value is approaching 0. And as x gets, I think this is supposed to say negative infinity. Yes, okay, as x gets really, really small, as I go towards negative infinity, again, it's hanging out here at this line, the horizontal asymptote, y equals 0. Now this one, as I go to infinity, I go this way, and I notice this is just going up and up and up. So it's not approaching any horizontal asymptote. This just keeps getting bigger. So it's going to infinity. And this one's going up and up too. It's also going to infinity. So you don't always have a numerical value when you're approaching infinity. Some graphs have horizontal asymptotes, some do not. So these are some theorems about as x approaches infinity, what happens. And I'm going to simplify all of this down here, okay? So I don't want you to get too caught up in that. There's essentially just a few rules when you're finding limits of infinity. What I want you to look at is the biggest power. And I want you to just think the biggest power rules, okay? Anytime you're looking at x approaching infinity, I want you to think the biggest power rules when you're looking at polynomial, okay? So polynomial means a fraction. I'm sorry, a rational fraction. A rational function, I can't talk. A rational function means a fraction, okay? So when you're looking at a fraction of functions, small over big, if you have a smaller power on top and a bigger power on bottom, think about what's happening. The top is not growing very much. The bottom is growing relatively very big, really quickly, especially if you're multiplying by huge sums. And, 1 million squared is way bigger than just 1 million. So the bottom is getting way bigger, way faster, and the top is not. So anytime you're dividing by some huge number, your overall fraction would be approaching 0. Whereas if you had big over small, if you have x squared over x, so you have 1 billion squared over 1 billion, that top is growing faster than the bottom, and so that's blowing up. It's going to infinity or negative infinity. But big over small, I just say it's a bunch of BS. The answer doesn't even exist. And then your other situation is if you have the same power. So same power, which is like ax to the n plus some other stuff, bx to the n plus some other stuff. So these powers right here are the same. Then they're growing at a relatively same rate. And what you're left with is the ratio of the coefficients. So a over b. And this will make sense as we do examples, but it's pretty much just these 3 rules. Very simple. Small over big, 0, big over small, bunch of BS, it doesn't exist. Same as the fraction. So on top, I have no x's. On bottom, I have x squared. So this is small over big, so my answer is 0. Again, this is only when we're taking limit as x approaches infinity. This is not for whenever x is approaching constants, which is what we talked about last section. As x goes to negative infinity, okay? Well, as x goes to negative infinity of this guy, again, this is just going to be negative infinity. Plug it in here, the biggest power rules. Negative infinity cubed is going to be negative some huge number. So this is approaching negative infinity because it's just getting bigger and bigger, but it has that negative sign. So you can also write doesn't exist. Both of these are correct. Now let's look here. This is a rational function. Okay, it's a ratio, it's a fraction of functions. So I look on top. I don't care about any of these guys because I'm just looking at the biggest power. The biggest power is 5. The biggest power here is 6. Which one is bigger? The 6. So this is small over big. And small over big goes to 0. It's really that simple because you're at huge numbers. So it's just looking for the biggest power. Now, what do you notice about this one? It's going to negative infinity. We can treat it the same for this problem. 3 and 3, I don't have to worry about this. These are the same. So it's the ratio of their coefficients, which is understood to be 1. So your answer is just 1. Biggest power here is 4. Biggest power on the bottom is 2. So that's big over small. So your answer is doesn't exist. Horizontal asymptotes. Horizontal asymptote is the same math we just did. It's just you can say y equals your answer is the horizontal asymptote. So horizontal asymptote, I have a little saying to help you remember. To find HAs, that stands for horizontal, look with this infinity sign, look both ways. That means just take the limit as x goes to infinity and negative infinity. So again, if I'm taking the limit as x goes to infinity of 1 over x, that's small over big. So my answer is 0. And if I take the limit as x goes to negative infinity, it is still small over big, which is 0. So you just have the horizontal asymptote of y equals whatever answer you got. So to find HAs, you look all the way at infinity and all the way at negative infinity. To find HAs, look both ways. So find the horizontal and vertical asymptotes. If I want to find the horizontal asymptote, I take the limit as x goes to infinity, t squared over t squared plus 9. So the biggest power here squared over squared, so it's same power, and so you just take this coefficient, which is just 1. So y equals 1 is your horizontal asymptote. Find the vertical asymptote, you cancel out things if they can be, you set the bottom equal to 0. Well, here, you're never going to get anything that's squared that equals -9. That's an imaginary number. This doesn't have any solutions. So you don't have any vertical asymptotes for this problem. For this one, I'm going to, let's take the limit as x goes to infinity. As those are, I just look at on top, that's squared, so it's just 2x squared over 2x squared. So that's just 2 over 2, which is 1. So y equals 1 is your horizontal asymptote. I don't have to worry about negative infinity because it's squared. So your behavior for the negative is going to be the same. You really have to worry about those when you have a square root or absolute value, something like that, where you have to check the signs. Or exponential function. I have to look and see if our course even covers that. Okay, so now to find vertical asymptotes, remember you need to factor first. So I'm going to have 2x, x, how do I get 12? Let's see, 3 and 4. If I do 4 and 3, that would give me 8 and 3, which is 11. Okay, and then let's try to factor the bottom. I want it to be 5 there, so let's see. 2 and 6, 6 and 2, 3. Can I factor the bottom? Wait, is that, hold on. The -12. Okay, so that's, let's see. If I do, this would be 12 and 2, no. Oh, it's the same. Okay, so this is 8 and 8 minus 3. Sorry, I don't know why that took me so long. Okay, I'm going to break apart there. 8x minus 3x, that gives you plus 5x. So these simplify. Remember, you're going to simplify first. That means that this is a whole. It's called a removable discontinuity. This one left over, you're going to set equal to 0. So 2x minus 3 equals 0 when 2x equals 3 or x equals 3/2. So that is your vertical asymptote. Horizontal asymptote is when you look at the powers. Vertical asymptote is when you factor, simplify, and whatever is remaining on the bottom, you set that equal to 0 and solve. Okay, so that is section 2.2. Attempt your assignment and please reach out if you have any questions.